Okay, notes 1.3, zero and negative exponents is what we will be talking about right now. Please turn to page 8 of your notes. Question number 1 says, use the power of a quotient property to simplify each expression. Write the quotient as an exponent. So, for example, in the first chart, you have the information filled in for you. 3 to the 5th power divided by 3 to the 2nd power. Remember that when you divide, you must subtract exponents. Okay, so we're going to subtract our exponents and see what ends up happening. So, let's take a look at 3 to the 5th power divided by 3 to the 3rd power. You should end up getting 3 to the 2nd power. Okay, and then 3 to the 5th power divided by 3 to the 4th power, you should get 3 to the 1st power. And then lastly, 3 to the 5th power divided by 3 to the 5th power, when you subtract the 5 minus 5, you end up getting 0. So you end up getting 3 to the 0th power. Okay, so now let's look at question number 2. It says, sorry, it's not even question number 2. We'll just look at the question underneath the chart. What expression did you write for 3 to the 5th divided by 3 to the 5th? What exponent did you use? So we ended up getting 3 to the 0th power. So that means that 0 is the exponent. Okay? So what does that mean? What does it mean to have 3 to the 0th power? Well, using factored form, it says find the value of 3 to the 5th power divided by 3 to the 5th power. Remember, we kind of talked about this before. If you take 3 to the 5th power, that just means you've got 3 times 3 times 3 times 3 times 3, right? And then in the denominator, you're going to do the same thing, so you end up getting 3 times 3 times 3 times 3 times 3. Now, if you have the same thing in the numerator as you do in the denominator, you can cancel them out. But the question is, what do they become when you cancel them out? Well, hopefully you know that 3 divided by 3 should give you what number? Hopefully you said 1. So this cancels out to give you 1. This cancels out to give you 1. All of these cancel out to give you 1. But remember, it's all multiplication, right? So these are all being multiplied together. So you end up getting 1 times 1 times 1 times 1 times 1. Well, 1 multiplied by itself any number of times, no matter what number of times it is always going to be 1. So that means that 3 to the 0th power is equal to the number 1. Okay? So question 3, based on your findings, what can you conclude about the value of 3 to the 0th power? So you should end up getting 1. All right? And then question number 4 says, make a prediction about the value of any number raised to the 0th power. So go ahead and see if you can do number 4. Pause the video and then come back to me when you think you have an answer. Okay, so we're not going to see the answer about this right now. And then question number 5 says, use a calculator to check your prediction for several numbers. Is your prediction right? So what I'm going to do is I'm going to open up my calculator right here, and I'm going to try a bunch of numbers raised to the 0th power, okay? So let's try 6, raise that to the 0th power. This button right here means raise to some power. So 6 to the 0th power, do you see this right here? It says 6 caret 0. That means 6 to the 0th power. You end up getting 1. Interesting. Okay, let's try another example. Let's try 9.2176 all raised to the 0th power. You end up getting 1. Okay, so now let's try pi. Let's see what happens if you take pi and you raise it to the 0th power. Pi raised to the 0th power equals 1. Awesome. So hopefully your prediction is that anything raised to the 0th power will always equal 1. A lot of people will think that anything raised to the 0th power will equal 0, but that's incorrect. It's always 1. And let me explain a little bit more to why it's always 1, okay? So remember how we said that 3 to the 2nd power just means 3 times 3, right? But there's always an invisible coefficient of 1, right? So it's 1 times 3 times 3, right? If I have 3 to the first power, I've got an invisible coefficient of 1, so it's 1 times 3. So if I've got 3 to the 0th power with my invisible coefficient of 1, it's 1, and then this means there's no zeros left over, so it's got to be 1. So anything to the 0th power is always 1, okay? So let's read what this says. A non-zero number raised to the 0 power is equal to 1. So a to the 0th power is equal to 1. Now, the directions here, sorry, I don't know if it looks like this on your paper, but it says to simplify each expression, okay? And evaluate where applicable. We're not going to do all of these questions, but we're going to do some of them, okay? So if I have 7 to the 3rd power, what this really technically means is 7 times 7 times 7. And then if I have 7 to the 0th power, I have no 7, so I end up getting 7 to the 3rd power. But another way to think about this, ladies and gentlemen, is that it's just 7 to the 3rd power times, what's this number right here? 1. Well, anything times 1 is itself, so you end up getting 7 to the 3rd power. Now, don't get that confused with 7 to the 1st power. 7 to the 1st power is not 1. 7 to the 1st power is 7, while 7 to the 0th power is equal to 1. Okay, so let's take a look at number 8. Number 8, you've got multiplication first, so let's multiply our numerators. When you multiply, hopefully you remember that you should add your exponents, so you end up getting 4 to the 8th power, and then I'm just going to copy the denominator, divided by 4 to the 8th power. Now I have to subtract my exponents, so I get 4 to the 0th power, but anything to the 0th power is equal to 1. All right, and then number 9 says a to the 4th power divided by a multiplied by a to the 3rd power. Okay, so I'm going to rewrite this in a slightly different way. A to the 4th power divided by anything raised to the 0th power is always 1. And then I'm going to copy the rest of the problem down, times a to the 3rd. Now, anything divided by 1 is itself. So I end up getting a to the 4th power times a to the 3rd power, which is a to the 7th power. That's one way to think about it. The other way to think about it is as follows. We could just say that when you divide, all you have to do is subtract your exponents. So 4 minus 0 is 4. So I end up getting a to the 4th power. And then copy the rest of it down, times a to the 3rd power, you end up getting the same answer as a to the 7th power. So you can think about it several different ways and you'll end up getting the same answer. All right, ladies and gentlemen, question number 10. Use the quotient of powers property to simplify each expression. Write the quotient in exponential notation. What we're going to do with this example right here is the most complicated topic of the entire unit. So please make sure you are really totally with me in understanding what it is that I'm talking about, okay? So again, 4 to the 5th power divided by 4 to the 3rd power, all you have to do when you're dividing is subtract your exponent. So you're not getting 4 to the 2nd power. All right, so here, when you divide your exponents here, when you divide the expression, you should subtract your exponents. So you end up getting 4 to the 1st power, okay? And then in the next expression, you end up getting 4 to the 5th power divided by 4 to the 5th power. Subtract your exponents, you get 4 to the 0th power. Hopefully you can fill in for me what number this is equal to. And hopefully you know that it means that it's equal to 1, okay? And then, here's where things get a little bit more complicated. I'm going to subtract my exponents in this expression right here, but when I do 5 minus 6, I end up getting a negative exponent, right? Because, remember the scoreboard strategy that you learned, team positive won 5 points, team negative won 6 points, so team negative won the game by 1 point, so the answer is 4 to the negative 1st power. And then when you do the next one, you end up getting 4 to the negative 2nd power, okay? So it says, what expression did you write for 4 to the 5th power divided by 4 to the 6th power? You should say that you got 4 to the negative 1st power, and the exponent that you used was negative 1. All right, ladies and gentlemen. So then, using factored form, find the value of 4 to the 5th power divided by 4 to the 6th power. So what this means is I'm going to write out everything right here. Now here is where it gets tricky. Please listen very carefully, okay? So 4 to the 5th power means 4 multiplied by itself 5 times, right? And then 4 to the 6th power means 4 multiplied by itself 6 times. All right, so now what ends up happening is these 4's cancel out to give you 1. These 4's cancel out to give you 1. These 4's cancel out to give you 1. These cancel out to give you 1. These cancel out to give you 1. Notice you have an extra 4 right here. So I end up getting 1, because 1 times 1 times 1 times 1 times 1 is 4, or is 1, excuse me. 1 times 1 times 1 times 1 times 1 is 1, over all of these 1's are being multiplied by 4, so I get 1/4. So that's what 4 to the negative first power means. It means 1 over 4, or more simply, 1 over 4 to the first power. So maybe you can start to understand what this negative exponent does to your expression. Well, we're going to try another example to truly see if we can understand what the negative exponent does to your expression. So again, using factored form, we're going to do 4 to the 5th power divided by 4 to the 7th power. So how many 4's am I going to write on top? Hopefully you said that we should write 5 4's on top. 1, 2, 3, 4, 5. And hopefully you understand that you will write 7 4's on the bottom. And these 4's cancel to give you 1, cancel, 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 cancel. So you end up with 1 on top. And then you've got 4 times 4 on the bottom. But hopefully you understand that 4 times 4 is 4 to the 2nd power, right? So remember we said earlier that 4 to the 5th power divided by 4 to the 7th power is 4 to the negative 2nd power right here. So that means that 4 to the negative 2nd power is equal to 1 over 4 to the 2nd power. So basically what this means is you're going to take whatever exponent you have here, if it's negative, and you're going to flip the fraction or do the reciprocal. So I want you guys to write down that it is the reciprocal. So basically, 4 to the negative first power really means, if you look at this right here, this really means 4 to the negative first power over 1. Notice how, if you have 4 to the negative first power, it flips over and the negative exponent becomes a positive exponent. So in general terms, a to the negative nth power means I'm going to have 1 over a to the nth power. And I understand this is something that might be confusing to you. And we're going to do some more practice so that you can understand this a little bit better. So question number 13 says, how would you write a to the negative 3rd power using a positive exponent? Remember, negative exponent means to do the reciprocal. Okay? So I'm going to take a to the negative 3rd power. It's technically over 1. So that means I'm going to do the reciprocal. The 1 in the denominator will now flip up to be in the numerator. And once I do the reciprocal, my exponent is allowed to become positive. So you flip these two right here and change this into a positive. All right? So number 14, simplifying each expression. Write your answer using a positive exponent. I'm going to show you how to do number 14 two different ways so you can understand both methods, okay? So the first way that you can do is just basically, when you have multiplication, all you have to do is add your exponents. So you end up getting 13 to the 3rd power, okay? But another way to think about this is this means it's 1 over 13 to the 4th power, right? Times 13 to the 7th power. And then this technically has an invisible over 1 right here. So you end up getting 13 to the 7th power divided by 13 to the 4th power, which ends up giving you 13 to the 3rd power. Okay? Now obviously you're going to want to do it this way because this way makes more sense, but I want you to understand that both methods are related to each other. Okay? So now let's look at question number 16. Number 16, there's two ways to look at it. Again, the first way to look at it is that you have 4 to the 8th power times 4 to the negative 10th power. All you have to do is add your exponents, so you get 4 to the negative 2nd power. However, the directions say write your answer using a positive exponent, and this is not a positive exponent, it's a negative exponent. But since it's negative, it just means I gotta take my number and do the reciprocal. Since this is over an invisible 1, this becomes 1 over 4 to the second power, just like that, okay? All right, another way to think about it is as follows. 4 to the 8th power can just stay as 4 to the 8th power over 1, and then this becomes the reciprocal, so it's times 1 over 4 to the 10th power. So you end up getting 4 to the 8th power over 4 to the 10th power. And now I want you to think about this in a slightly different way. When you are dividing, you're just canceling factors out. So on the top in the numerator, you have 8 4s being multiplied together, okay? And in the denominator, you have 10 4s being multiplied together. So think about this next question logically. If my 4s cancel out, how many of them will cancel out? Well, if you have 8 on top and 10 on the bottom, 8 of them are going to go away. How many are you going to have left over? Well, if there were 10 on the bottom and 8 of them went away, you have 2 left over. So that means you have 2 left over, but you have more in the denominator. So that's why you'll end up getting 4 to the second power in the denominator, and everything canceled out in the numerator to give you 1. So either way, you'll get this answer right here. Okay? In number 17, when you divide, you should subtract your exponents, right? So you end up getting negative 7 minus negative 4. Remember, this becomes a positive right here. So you end up getting negative 3. So your answer is x to the negative 3rd power, but we need to write our answer as a positive exponent, so I get 1 over x to the positive 3rd power. There's multiple ways you can look at that question as well. All right, number 20 is the last question we're going to look at together. So if I have negative 6 to the 3rd power divided by negative 6 to the 4th power, I'm going to show you 2 different ways to do this. The first way that I'm going to have you look at is just the fact that we're dividing. When you divide, you should subtract your exponents. So you end up getting negative 6 to the negative 1st power. Now this negative has nothing to do with the exponent. It means that the number itself is a negative number. This exponent that's negative means that you have to do the reciprocal. You got to flip your fraction. So you end up getting 1 over negative 6 to the 1st power, okay, or just 1 over negative 6. Okay, the other way I want you to look at it is the same way we looked at this 4 to the 8th power divided by 4 to the 10th power. Imagine that you have 3 negative 6s being multiplied together on top and 4 negative 6s being multiplied together on the bottom. So 3 of them will cancel out and you will have 1 left over. But where is that 1 negative 6 going to be left over? It's going to be left over in the denominator, right? Because there were more in the denominator than there were in the numerator. So then you have to put a 1 as a placeholder on top, so you end up getting 1 over negative 6. Don't worry if this was confusing to you. Please go back and re-watch some of the parts that were confusing to you. But don't worry, we will also do some practice with this stuff in class.